Differentiation 2, second derivatives, type 2 differential equations. So when we're looking at these differential equations, the question is basically going to ask us to show that a given statement is true. So in this given statement, we'll inevitably be asked to show that the first derivative and the second derivative and the original function are going to somehow simplify so that the left-hand side is equal to the right-hand side. So therefore, the first thing we would have to do is our step 1, where we'd find our derivative, our first derivative. We'd simplify that and then find the second derivative. Simplifying the second derivative, we would then take the original function, the first derivative, the second derivative, sub it into the given equation, and simplify, showing that the left-hand side is equal to the right-hand side. Okay, so let's have a look at an example of one of these given statements. So here we have to show that the second derivative plus 4 times the first derivative plus 4 times y is equal to 0, given that y is equal to x e to the minus 2x. So I'm going to put brackets around any of my products. So I can see I have the first derivative, so I'm going to have to multiply my first derivative by 4. I'm going to have to sub in my second derivative, and I'm going to also have to multiply 4 times y, which is the original function. And if I look at the original function, I have a function of x multiplied by a function of x. So therefore, if I take y equals x times e to the minus 2x, in order for me to find dy dx, my first step, I have to use my product rule, because I have a product of two functions of x. So to the side, if I take u, and I say u is equal to x, then if I get du dx is 1. If v is equal to e to the minus 2x, then dv dx is equal to minus 2 times e to the minus 2x. So in other words, if I differentiate e to the minus 2x, I get e to the minus 2x, in other words itself, times the derivative of the power there, which is minus 2x. So differentiating minus 2x, I get minus 2. So now I have u du dx and v dv dx. I have to sub that into my product rule. So again, if I go to page 25 of my maths tables, I can see my product rule here is going to be dy dx is equal to u times dv dx plus v times du dx. So I'm going to simplify that before I move on. So that's going to be minus 2x e to the minus 2x plus e to the minus 2x. So you could take that as your second derivative, in which case you'd have product rule and then you'd have e to the minus 2x. But I'm just going to tidy that up one more step, because I see that I have an e to the minus 2x in both of those terms. So if I take out e to the minus 2x as being common, well, that leaves me with minus 2x plus 1. And now I just simply have one product rule to apply. So I'm going to repeat the process. So I'm going to say, well, u is equal to e to the minus 2x. So du dx is again minus 2 times e to the minus 2x. So the derivative of e is itself. And again, I can see that here in my tables. And then times the derivative of the power of e, which is minus 2. v is equal to minus 2x plus 1. Therefore, dv dx is equal to minus 2. So if I sub in for my second derivative, I'm going to have, so u times dv dx plus v times du dx. So again, if I was to get rid of my brackets there, I have minus 2 e to the minus 2x, and then I have minus 2x plus 1 times minus 2 e to the minus 2x. And again, I can see I have an e to the minus 2x. So again, I'm just going to tidy that up by taking that out as being common. You don't have to. You could multiply out your brackets, of course. and add any like terms. But if I take out e to the minus 2x as being common, well, that leaves me with minus 2, and then minus 2x plus 1 times minus 2. So again, tidying up that inner bracket there gives me e to the minus 2x minus 2 plus 4x minus 2. So that gives me my second derivative is e to the minus 2x times 4x minus 4. Okay, so now I have my second derivative, I have my first derivative, and I have, if I go back to the top here, my original function y. So if I star that, they're going to now be subbed into this equation, and I'm going to take the left-hand side and then hopefully simplify that to give me my right-hand side equal to 0. So I say left-hand side. So my left-hand side is the second derivative plus 4 times the first derivative plus 4 times the original function. So my second derivative there we said was, if I scroll down, so e to the minus 2x by 4x minus 4. And then I have 4 times the first derivative, which is e to the minus 2x times minus 2x plus 1. And then I have 4 times y. And y we said was x times e to the minus 2x. Okay, so again, I could multiply out my brackets and then add all my like terms, or I can see, well, I have an e to the minus 2x in each of these terms. So I'm just going to take that out as being common. And then I'm left with, inside the brackets, 4x minus 4 plus 4 times minus 2x plus 1 plus 4 times x. So if I simplify that second bracket, I have 4x minus 4 minus 8x plus 4 plus 4x. And then I can go, well, 4x minus 8x is minus 4x plus 4x is 0, and minus 4 plus 4 is also 0. So that leaves me with e to the power of minus 2x multiplied by 0. And of course, 0 times anything is 0. So therefore we can say, well, that means that the left-hand side is equal to the right-hand side. And of course, in any proof, show, or investigate, we have to always have a conclusion. And our conclusion is the original statement that the second derivative plus 4 times the first derivative plus 4 times the original function is, in fact, equal to 0. So if we go to page 357, and if we do questions 7, 8, and 10.